Okay, so chapter 5, and we're going to start looking at Newton's laws. So the first thing I wrote in here was that the SI unit of force is newtons. I just kind of wanted to get that over and done with straight away, just so you're all clear on that. SI unit of force is newtons. Okay, so the next set of notes really just goes over types of forces and introduces you to some of the language that we use to describe forces. So if we just quickly go through these now. So an object only experiences a force if it is in some way in contact with either some other object, these are called contact forces, or some force field. These forces are acting at a distance. Okay, so these next set of notes, as I say, just run over some of the different types of forces. And at the end of this video, I'm just going to talk about the difference between mass and weight, and then I'll produce a video on each of Newton's first, second, and third laws as well. So this one is just really an introductory video to forces. Okay, so forces due to other objects. So we'll just go over the concepts of some of these forces. So we have firstly the normal reaction force, N, and this force is perpendicular or normal to the surface. So perpendicular or normal means it makes a right angle with the surface. The diagram opposite shows the normal reaction force exerted by a table on a book. And because, so everything is acted upon by gravity, so we could draw in another vector here, and this would be representative of the force due to gravity, which is equal to mass times the acceleration due to gravity. And because this book is not either falling through the table or floating up into space, we'd say that the normal force and the force due to gravity are equal. So we can say that they're equal forces as well. Okay, so normal force is acting perpendicular to a surface. Another type of force that you'd be familiar with is the friction force. And here we have this force is parallel to the surface. It hinders movement of an object over a surface. The diagram opposite shows the frictional force acting on a book, which is moving along a table. So the important concept of friction is it acts in the opposite direction of the movement due to the contact between the object and a surface. Another example that you might be familiar of is if you were, say, trying to slide. So if you tried to slide across a floor, let's say that was a wooden floorboards, compared to carpet. Okay, you know that it's going to be easier, if you're just wearing socks, it'd be easier to slide across a wooden floorboard than it is to slide across carpet. And that's because there's more frictional forces with your socks and the carpet compared to socks and the wooden floorboard. So friction, so you probably know all about friction. Drag force here. Okay, so if you would have experienced drag force if you've ever run against the wind. Okay, so the drag force, you experience a higher drag force the faster you're running, or maybe if you're riding on a push bike, you might, like if you're riding faster, there'll be a higher drag force than if you were riding slowly. So it's just the force of the air particles against whatever object is moving through them. Buoyancy force that allows us to float. Okay, buoyancy force, and I encourage you to read the extra notes in there as well. Lift force, this allows aeroplanes to fly as well. Tension force, it's another important force for us in this course. Basically, if you attach a rope to anything and you pull on that rope, you're applying a tension. There's going to be tension along that rope. And as you notice from this diagram here, the tension force, we can draw that acting in the direction of the rope as well. Okay, so thrust, when we're talking about jet engines or rocket engines, we're talking about thrust, and it's pushing against a fluid. So often when we come to doing Newton's third laws, we'll talk about a rocket exerting a force on gas particles and then gas particles exerting a force on the rocket, and that produces a thrust in the direction that we want it to go in. Okay, so the other concept that I wanted to focus on today is really the difference between mass versus weight. Okay, so the difference between mass versus weight. So if you look here, we say gravitational force and is equal to mass times gravity, and we call that the weight force. So the difference between mass and weight is that weight is a force. Oops. Which is measured in newtons. And mass is measured in kilograms. Okay, so what scales actually do when you measure your mass is they actually convert the weight force, and they give you a readout in kilograms. So they convert the weight force into a unit of mass. But the thing about mass is constant. So it does not change. Oops, is constant. Get rid of that. So your mass is constant, but your weight can actually change. So let's say if you went to the moon, you'd still have the same amount of kilograms, so that would be your mass, but your weight would be less because the force due to gravity is less. So if your weight force here is equal to your mass times gravity, then the weight due to gravity will change on the moon compared to the weight of gravity on, or the force of gravity on Earth. And so you can actually test this by, if you stand on scales in an elevator, then you can actually test this, and you should see a change in the scales when the elevator is going up and down. I'll just make a little note here. Test this by standing on scales in an elevator. Okay, and I'll just finally write the last note here was weight changes depending on the acceleration of gravity. Okay, so that was just a quick introduction to the types of forces that we'll cover in this course. If you have any questions, feel free to email me those, and we'll look at Newton's laws in the next videos.